This is question 4 of the P1.4 end of topic test. On screen now is the mark scheme for the question, so please mark your work. Remember to correct all your answers in green pen. If you get the question correct, I suggest you move on. If you get the questions incorrect, please listen to the rest of the recording to find out how to answer the question correctly in the future. Just one point to emphasise is that part A is actually a mistake of the mark scheme, and that should read the answer should be 2004, not 2005 like the mark scheme says. You may wish to pause the recording now so you can mark your work. So here's question 4A. It says that the graph shows the expected change in world demand for energy. It also shows how supplies of various energy sources resources are expected to change. It asks you to use the graph to estimate when supplies from oil and coal are equal. So you can use the graph and look for oil, and you're also going to look for coal. So here's coal, and there's oil. And you want to see where them two are equal. So they're going to be equal at that point there where the two lines cross. And so they're going to be equal. As you can see, that's 2000 here and 2005's there, and it's in between. So that answer should be 2004. Give yourself a tick for that. Part B of the question mentions that currently we rely on coal, oil and gas to supply most of our energy needs. Actually, to use the graph to explain why we must develop alternative energy resources. So looking at the graph which is over here, you can see that we've got energy up this side, and we've got the year going this way, reaching 2030. And then we can see that this line here is the world demand going up this way. So you can see at the moment, around 2000, well, when the graph was first created in 1990, a combination of coal and oil would potentially reach demand. Including natural gas, you have definitely seen that you have reached demand. As we head towards 2030, you see that adding these lines here is not going to make up to the total of the world demand energy. So what you need to now do is put that into your own words. So I've just now dropped in the answers. So you can see there the idea that reserves of coal, oil, gas are being depleted. So the graph doesn't quite show that coal is being depleted because it sees an increase in coal, but you can see that oil is going down and natural gas is slightly going down as well. So the idea that those are going to run out. The idea that demand for energy is growing at a faster rate than total energy supply, so you can see that the world energy demand is a lot higher than what we're getting from these ones, and that basically the traditional fuels will not be able to meet the demands of the future. I personally think that these two answers are the best, because that's actually what the graph shows, whereas the idea that the reserves of coal, oil and gas are being depleted isn't necessarily shown by the graph. But that's just something that you should have known from the topic. Moving on to part C then, we've got on average the energy use of each family in the UK releases 25 tonnes of carbon dioxide and 4 kilograms of sulfur dioxide into the air every year. He wants you to explain the environmental impact of releasing carbon dioxide into the air. That's going to be global warming. Okay, you could also have the greenhouse effect there. They're both worth 1 mark. The next one says state a different environmental effect caused by releasing of sulfur dioxide into the air, and that would be acid rain. And again, you should have just known that from the topic, as we've covered that. Finally, it says nuclear power stations use energy released by nuclear fission to generate electricity. Explain what is meant by the term nuclear fission. That is the idea that you split a nucleus of one larger atom to form 2 smaller nuclei. In the mark scheme, what they were looking for is that you mentioned neutrons in there, so you use a neutron to split the nucleus. But I personally think that answer there, plus the and neutrons are being released and energy, would also be sufficient to get you the marks. It would be worthwhile to note that you should really have the idea that a neutron is required to start a process. So remember, you fire a neutron in to the nucleus of one large atom, it then breaks down into 2 small nuclei, releasing 2 or more neutrons and energy. We now move on to the hardest question on the paper, in my opinion. It says here, 200 megawatt coal burning power station provides all electrical power for a small island. The coal is brought to the island from the mainland. You can see you've got a diagram here where you've got it 20 kilometres across and 30 kilometres down. You can see the coal mines over here, and this is the island. This is the islanders want to replace the power station with the wind turbines and have been given the following information. What they would like you to do with that information is they would like you, would you recommend that the islanders replace the coal power stations with wind turbines? Explain the reasons for your recommendation. To gain full marks, you must support your explanation with relevant calculations. That bit there is key. We must do calculations. So, we want to try and figure out if we're going to be able to produce enough power to meet the 200 megawatt coal burning power station by using wind turbines. Okay? And how we're going to do that is we're going to have to find out the maximum number, or the maximum power output from a wind turbine. And to be able to do that, we first need to know the number of wind turbines and then the maximum power output from each one. So we're wanting to find out the total power, which I'm going to use as P, from wind. And that will equal number of turbines times the power of 1. That should be max power. That's the equation I'm going to use. So total power from wind is equal to the number of turbines multiplied by the maximum power of 1 wind turbine. So that's what we've got to do. So the first thing that we're going to try and look at is the number of turbines that we can get on there. So we want the number of turbines. So I'm going to highlight the information that we've received in this question that will be relevant for us to find out the number of turbines. So we can find out the maximum number of turbines on 1 kilometre square of land, and then the percentage of the land suitable for wind turbines, and then we've got this information here that says 30 and that says 20. So we're going to find out the area first. So the area equals 20 times 30, which gives us 600 kilometres squared. So that's the total area of the island. Okay. Now I want to know the percentage suitable. So the area that's suitable equals, you can see here we've got the 20%, let me just highlight that for you. Percentage of land suitable, 20%. Okay, so to work that out, we're going to do 0.2 times by our 600. That's going to give us an answer of 120 kilometres squared. Okay, and that's the area suitable. Now I want to know the number. So the number of wind turbines. And there, we're going to use this bit, let me highlight it again. You get 6 on 1 square kilometre of land. Well, we've got 120, so we're going to do 6 times 120. And that's going to give you 720 turbines. So we're going to use that. So we've got 720 wind turbines that we can use going to the next question. Next part of the question, where we're going to find out the maximum power of one of them and then combine that together. In this part of it, we're still looking at the same question. We've got power from the wind is equal to the number of turbines multiplied by the power of 1. Now we've got 720 wind turbines. We now want to work out the power of 1 and then multiply that number by 720. So it tells us here that the maximum power of the wind turbine is 800 kilowatts. That's the maximum output from a turbine. The average yearly output as a percentage of the maximum is 0.25%. So therefore, the yearly power of 1 is going to equal the 800 multiplied by the 25%, so that's 0.25, which will give me a maximum power of 200 kilowatts per turbine. Now the next point of it is to combine those two numbers, so we're going to do 720 times 200 kilowatts, which will give us an answer, and then we'll compare that to the power produced by the coal burning power station. So we've been working this out. So we've got power from wind is the number of turbines multiplied by the power of one turbine. If we take this down here, that we got that the power is going to equal, we found out we had 720 wind turbines multiplied by the power of one being 200. And that comes out to give us an answer of 144,000 kilowatts. So that's the amount of power that's produced by wind turbines. We need to compare that to 200 megawatts produced by coal. So 200 mega is 200 million. Okay, watts. So that would look like, that would be 200, 123 watts. Whereas our power is 144,000 kilowatts. So we 144,000. So it's relatively close, but you get more from the coal. So the answer is, so would we recommend that? The answer there would be no, we can't recommend it because we don't get enough energy provided by wind to replace the coal power station. So you would not recommend it for the islanders. If you've got any more questions about that calculation, it is quite involved, very difficult for a GCSE calculation, especially a Unit 1 calculation. I suggest you speak to your physics teacher and they may be able to explain it a little bit better, or in a different way that might make you understand. If you just turn your attention to the top of the page now, just drop to the mark scheme. So the marks are for saying no to the total power being sufficient, that gets you 1 mark. If you've worked out that you've got 720 wind turbines, that's you 1. If you've worked out the maximum power would be 144 megawatts, or 144,000 kilowatts, or 144 million watts, that's the other one, and that's how you get the 3 marks in total. However, there is 1 mark for saying that the total number of wind turbines would create no visual or noise pollution, or 1 mark for saying yes, it would reduce CO2 from transport. Okay, so if you got the question wrong and you said yes, you should build wind turbines, you can get up to 2 marks using either of those ones. The final part of this question says some islanders want to find out if it will be possible to generate electricity they need using solar energy. How could the islanders find the data needed to make an informed decision? Well, with that one, what they're looking for is that they could use the internet to make the informed decision, or speak to the manufacturer. So speak to the manufacturers, and that way either one of those would get you a mark. Some people have they carry out their own experiments. Not convinced that the islanders would necessarily do that, but I'm willing to accept that as an answer. So if you put they carry out their own experiments, then perhaps we'll let you have that one for this time. And that brings us to the end of that question.